So we're going to review Unit 2 all about polynomials. The first question says, use the graph below to answer the following questions. And they're giving you a polynomial graph here. A, determine the number of distinct zeros. Remember that distinct means different. So how many different zeros do I see? Zeros is the same thing as x-intercepts, roots, or solutions. They are only x-intercepts if they are real. If they're imaginary, they won't show up on the x-axis. So if I'm looking at my x-axis, I have 1, 2, 3 distinct zeros. Identify the zeros and their respective multiplicities. So when I'm identifying these, I'm going to write them as an x equals. X equals -8, x equals -4, and x equals -2. Remember, multiplicity is the behavior of the graph at the zero. So if I'm looking at my x-axis at x equals -8 and at x equals -2, these are both what we call straight through. And because they are straight through, they have a multiplicity of 1. At x equals -4, this is a bounce. It's tangent to the axis because it hits my axis and turns back around. So that's a multiplicity of 2. This graph doesn't have any, but if it's a multiplicity of 3, it would be a squiggle at that value. That would be a squiggle, which is a multiplicity of 3. Part C, determine the number of local extrema. Local extrema just means turning points. In other words, your maximum and your minimum values. So remember that it's kind of like being on a roller coaster. You want to know where I go up and then I turn back around. So I'm traveling up from left to right. So up, 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 and right here I hit a maximum and I turn back down to go down. Then here I hit a minimum and I turn around to go up. Here I hit a maximum and then I turn back down. So there are 3 local extrema here. Part D, is the polynomial an even degree or an odd degree? Explain. So both arrows are pointing in the same direction. So because both arrows are pointing in the same direction, this is what we have as an even degree polynomial. Part E, does the polynomial have a positive or a negative leading coefficient? To determine a positive or a negative leading coefficient, we always go to the right arrow. My right arrow is pointing down, so it is a negative leading coefficient. And then lastly, part F, they want us to put everything together and write a possible equation for the graph. So equation, it has to have y equals or x, f of x equals something like that. So I have f of x equals, we're going to put everything together. I have a negative leading coefficient, so it's going to start out with a negative. You're going to take each of your zeros, there were 3 of them, and make them the opposite. So my 0 was x equals negative 8. So as a factor, it becomes x plus 8. And that's going to go in my first parentheses. My second 0 was x equals negative 4. So that becomes x plus 4. And my last 0 was x equals negative 2. So that becomes x plus 2. And then your multiplicities become your exponents. Those both had a multiplicity of 1, so you can leave it, or you can put the imaginary 1. That's up to you. And then lastly, my x equals negative 4 had a multiplicity of 2. So this would be a possible equation for your graph. Let's review some dividing, factor, and remainder theorem. Determine if x minus 4 is a factor of 2x to the third minus 4x squared minus 7x minus 10. Explain your answer. So if it's a factor, my remainder, which is my y value, is 0. So the quickest way to do this is to use the calculator. I'm going to go to the y equals and type in my polynomial. Then I'm going to go to my table, and I'm going to look at my y value. Specifically, I'm going to look, if my factor is x minus 4, I'm going to look at x equals 4. So I'm going to open up my calculator and go to the y equals to type that in. Second graph brings me to the table. I'm looking at x equals 4. It has a y value of 26. So determine if x minus 4 is a factor. X minus 4 is not a factor of the polynomial, and then I have to explain my answer. Because there is a remainder of 26. Making sure that I've shown my work by writing down my table and explained my answer. You could also divide, but you'd be taking a little bit more time. If you're dividing, synthetic would definitely be the way to go for this particular question, just because you want to save time for some of those more involved questions. Number 3, find the quotient. That's an answer to a division problem. When x cubed minus 11x squared plus 19x minus 19 is divided by x minus 1, and express your answer in the form q of x plus r of x over b of x. Don't be concerned with the notation here. All it's asking us to do is divide. So I have x to the third minus 11x squared plus 19x minus 19 divided by x minus 1. I'm going to review both tabular and synthetic. The first thing, regardless of which one you're doing, you always want to check for a placeholder. As long as you don't skip any terms in standard form from the highest exponent down, you're good. I have an x to the third, an x squared, an x to the first, and a constant, so I don't need to put in a placeholder. Let's do synthetic first. If I'm doing synthetic, I'm going to start by lining up my coefficients. 1, negative 11, 19, negative 19, and I have to determine what number goes on the shelf. To do that, you're going to take your divisor, set it equal to 0, and we're going to get x equals 1. So that's the number on the shelf. From here, you bring down the first number, and then you multiply, add, multiply, add, multiply, add. 1 times 1 is 1. Add straight down. Negative 11 plus 1 is negative 10. Negative 10 times 1 is negative 10. Add straight down. 19 plus negative 10 is 9. Multiply. 9 times 1 is 9. Add straight down. Negative 19 plus 9, negative 10. This last piece is always your remainder. And then you work backwards. This is constant, x to the first, x squared. So my final answer is x squared minus 10x plus 9 plus negative 10 over my divisor of x minus 1. You could put minus 10 over x minus 1, or you could leave it as I have it with the plus the negative. And then I'm just going to quickly review the tabular method as well. If you're doing the tabular method, your divisor goes on the right-hand side. So I have x minus 1. My dividend, or what I'm dividing, goes around the diagonal. So x to the third minus 11x squared plus 19x minus 19. And then based on that, I'm going to draw in my columns. You're always going to start in the top left corner because that has to match. This has to be an x to the third. If you want to set up your scrapwork on the side, you can. X cubed divided by x gives me an x squared up top. Once you get a top piece, you multiply. X squared times x is already there. X squared times negative 1, negative 1x squared. My diagonal has to add to that output. So this gives me a negative 10x squared. Then I divide. Negative 10x squared divided by x gives me negative 10x up top. Once you get a top piece, you multiply. Negative 10x times x is negative 10x squared. Negative 10x times negative 1 is a positive 10x. Diagonal adds, so this is a 9x up here. Divide 9x divided by 9 up top. Sorry, 9x divided by x. Up top gives me a 9. Multiply once you get the top piece. 9 times x is 9x. 9 times negative 1, negative 9. If this were to match as my output, I'd be done. But it doesn't, so there's a remainder. Negative 9 plus whatever my remainder is has to give me this output here of negative 19, which leaves me with a remainder of negative 10. So I end up with the same final answer that we did before. Remember also that you could always check your remainder by using the strategy in the calculator that we did in the previous question. You would type your original polynomial into y equals, and then you would go to your table and look at your remainder. Can't do that as your final answer because it only gives you the remainder, not the entire quotient, but it's a good way to check. And then lastly for this unit, we're just going to review how to find the remainder based on a graph. So you're going to determine the remainder by each of these binomials. So remember that your remainder is your y value. So for x minus 5, if I had an equation, I would go to my table in my calculator and I would look at the number 5. But instead of an equation, I have a graph. So instead of going to the table, I'm going to go to the graph and find x equals 5 and find that point. This is the point 5, 6. So my remainder would be 6. For x minus 7, I would be looking at the number 7 on the table in the calculator. So right there, this is the point 70. So my remainder is 0, which by the way means that x minus 7 is a factor. And then lastly, I would be looking at negative 2. So at negative 2, I have the point negative 4. So my remainder here would be negative 4. So that is a brief synopsis of Unit 2 for polynomials, dividing, remainder, and your graphs of polynomials.